Hey everyone, this is just a quick video to review with you how to write formulas for ionic compounds. So before we do these three compounds, which I believe should be in your notes in section 6.4, we need to just review a few things about the periodic table that you need to remember. So you need to remember that the columns on the periodic table correspond to different charges that the elements in that column have when they become ions. So the first column, they all become +1 ions because they lose one valence electron. These ones lose two valence electrons, so they become +2. The transition metals are all positive, but they can be various different charges, so we skip over those. These ones are +3, they lose 3 valence electrons. We skip over this column because they don't form ions super commonly. These ones are -3 because they gain 3 electrons. These are -2 because they gain 2 electrons. The fluorine column is -1, and then the noble gases don't really form ions, so it's like 0. So remember, +1, +2, +3, skip, -3, -2, -1, skip. Alright, so we're going to need to remember that as we write these formulas. Now, let's start with aluminum chloride. So we have to find aluminum, and it's going to be a +3. And then chloride, sorry, aluminum's right there, it's a +3. Chloride is right there, it's a -1. So we make our chart. Hopefully you guys remember we do these charts. They look like this. On this side, I put the cation, which is the element written first. So aluminum is a 3+. On this side is the anion. Chloride is a 1-. And then my goal is to balance the charges, so they need to add up to 0. So this is a +3, this is a -1. So to balance those, this side needs to be -3. So I need to add 2 more chlorines. And then if I look at the total charge, which I'm going to write up here, the total charge on this side is +3. The total charge on that side is -3, so they're balanced. And the formula would be AlCl3. Okay, this next one has Roman numerals. And Roman numerals mean you're dealing with a transition metal that is positive. Transition metals will always be positive. And the Roman numerals tell you the charge. So, if you look on your periodic table, lead has the symbol Pb. And then these Roman numerals are telling us that it has a charge of +4. So we put 4+. And then we look up oxide, which is just the name we give oxygen as an ion. So it's right there. It's in the -2 column. So it's a -2. So to balance those, we'd need another oxygen. That'll give us +4 right here and -4 right there. So it'll be PbO2. Okay. And the subscript is telling me how many oxygens I have. Hopefully that you guys remember that. Lastly, let's do calcium nitrate. Now, if your ion ends in 8 or ite, that means it is a polyatomic ion. So you should have a table in your notes in section 6, somewhere in chapter 6, that shows you the polyatomic ions. I'm going to show you a different table. If I can find it here. Oh, never mind. My book doesn't have it. But if you look on your table of polyatomic ions, you would see that nitrate is NO3 1-. If you don't have your table of polyatomic ions in your notes, if you just Google polyatomic ions, you can come up with lots of lists of them. Like, if you don't have it in your notes, you can find it on the internet. And then calcium, if we look on the periodic table, calcium is in the second column, so it's a 2+. So it looks like that. And then we need 2 of the NO3 nitrate ion to balance my +2. So I've got +2 and -2. And then to show that I have 2 nitrates, I need to put NO3 in parentheses and put the 2 outside the parentheses. Because if I don't, it's going to look like I have 32 oxygens, which isn't correct. All right, so that's pretty much all you need to know about writing formulas. Hopefully you guys feel pretty comfortable with this. You just needed a quick review. So there you go.